My name is Clayton Pierce, and this is video experiment number 3. This schematic is of the unmodified experiment, and basically what this experiment is a potentiometer is being powered from the 3.3 volt pin there, and when powered, when it's turned, it gives off an output between 0 and 1020. Analog pin 0 takes this output and uses the code inside of the board to give power to pin 13 depending on what the output of the potentiometer reads, making the LED blink in a specific pattern depending on the output.
Here is the physical experiment number 3. Like I said in the schematic, this potentiometer gives an output from 0 to 1020 that gets read by analog pin 0 here. The code in the board reads this output, and depending on what the output from the potentiometer is, powers pin 13 and the LED accordingly through this resistor. As you can see, when I turn this potentiometer, the frequency of blinks of the LED changes.
This is the code for unmodified experiment number 3. The first thing that's happening before the void setup is a variable called sensor pin is being created, and that value is given 0 to tell the code that the pin being used is analog pin 0. Next, a similar thing's happening where a variable called LED pin is being created to let the code know that pin 13 is being used. And next, that variable LED pin that was just made is being created as an output. So it knows that when you talk about that variable, we're talking about an output. The next thing that's happening in the void loop, so the code that's going to continuously run, is a variable called sensor value is being created, which is basically just a command here, analog read sensor pin, and as I said, sensor pin is pin 0. So analog read pin 0, which is connected to our potentiometer, is just now this variable sensor pin, making it easier to write. And this is the actual code here. It's digital write LED pin high, meaning turn on pin 13, the one connected to the LED output high, and then delay by sensor value, which is delay by the output given from the potentiometer. And then it's just turn off and delay by that same value. This is the modified experiment number 3. The physical modification is an LED wired in parallel with the first. Otherwise, the schematic is similar to the first half, which shows the potentiometer being powered from the 3.3 volt pin. Here's the power right here. The ground wire is right here below it, and the potentiometer has a value between 0 and 1020, which analog pin 0 here reads. Once analog pin 0 reads this, the code in the board, depending on what the value is, either gives off SOS in Morse code or my name in Morse code, and powers pin 13 accordingly to make the LEDs blink. This is the modified experiment number 3. What this now does is, depending on the 0 to 1020 value the potentiometer gives out, it will either make the LEDs blink in Morse code SOS or my name CLAY. If the value is from 0 to 5, it will make the LEDs turn off as they are now. If the value is from 5 to 500, it will make them blink in SOS, as I said, or if it's from 500 to 1020, it will make the LEDs blink in my name. So as you can see, if I turn this slightly to the left here, that's the C, that's the L, that's the A, and that's the Y. So if I turn it all the way more, after it goes through one more loop of my name, it'll update and it'll start blinking SOS. That's the S, that's the O, and there's the S. This is the code for the modified experiment number 3. The first thing that's happening is the same as the unmodified version. We are just making a variable called sensor pin and setting that to 0 to let the code know that the pin being used to read the potentiometer is analog pin 0. Next thing that's happening is still the same. It's similar to the thing before as well. It's just saying a variable called LED pin equals 13 to let the code know that the pin powering the LED is pin 13. I then have new code here, which is just a function called dash, which basically means turn the LED on high, output high, for 1,000 milliseconds, a long amount of time, and then turn off, output low, for this short amount of time to make it look like a dash on the LED in real life. Next, I have something similar, except it's the dot version. It's letting the LED turn on high, so it turns on for 100 milliseconds, which is a short blink, and then turn off for that same delay. This should actually be above what I was just talking about, but this basically just sets the LED pin variable that was mentioned up here to an output. So it knows that when you're talking about the variable up here, you're talking about an output to actually power the LED. This is in our void setup, just to set up the code. In our void loop, the code that will continuously run, the first thing I've done is make 7 integer variables. So they are just variables that are a constant number. And these 7 variables are for each of the 7 letters or 7 sections of code that I have, because I have SOS, which is 3 sections, and then I have CLAY, which is 4 sections. So I needed 7 variables. What these variables do is I have a while code. So that means that this code will only run while these different constraints are true. The constraints are, one of the constraints, and the reason that I need these variables, is that if the variable for that specific letter is less than 1, the code will run, and after it runs, it adds 1 to that variable, meaning that it will not accidentally run again before the other letters in the section are allowed to run. What this variable here, sensor value, means is just analog read sensor pin being the variable created before, analog pin 0. So when we're talking about sensor value, it's just saying read the output from analog pin 0, the potentiometer, and depending on what that output is, I've used the variable sensor value to make the while constraints. And for SOS, as I said before, if it's below 5, or above 5, and below 500, it will do the SOS code, which is what this here means. If it's below the 5, if sensor value is below 5 and above 500, and the times variable I made up here is less than 1, run this code, and then it'll add times, like I said, so it will not run again. And then it'll go to the next line, which is the O here, the dot dash dash dash, if it's less than 5 and above 500, and the same thing for the S. This is the function that I used before, the dot, which means turn on for 100 milliseconds, turn off for 100 milliseconds, and then it'll do that 3 times, and then have a delay of 1,000 milliseconds just to help you differentiate the letters. Like I said, the dash 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 function to make the O, which is O in Morse code, is dash dash dash, and then same delay with the same times plus 2. This time I just have it's just labeled so I can remember which one's which. And then finally the S again, which is the same code just with a new variable. Now, this is my name in Morse code. Instead of having the sensor value, which is the variable that gets read from the potentiometer being between 5 and 500, it's between 500 and 1020. So that means when you turn the potentiometer to this setting, it will run these 4 letters here, which is C, L, A, Y respectively. It does the same thing as SOS, it just makes the letter in Morse code using the functions I created. Dash dot is C with the same delay to differentiate. Dot dash dot dot is L with the same thing to differentiate. A is simple, it's just dot dash with the same 1,000 milliseconds to differentiate. And finally, it's dash dot dash dash with the same delay. And then everything else here is the same. It's pretty repeated code. It's simple just to allow the potentiometer to change what's being on the LED.